Okay, so let's start the class. For the test number 2, it will cover circular motion and it will cover Newton, everything Newton. So that's why definitively it's not gonna be this coming Tuesday. It might be Thursday or the following Tuesday. Okay, let's see how much we cover this week. So you really need to study from your textbook. I am not enough, okay? We only meet like twice a week and already we lose sometimes to the pop quiz, which is very important so you can assess what is missing for you. But you really have to study. You really have to do your homework without looking at the solutions. And you have to, in the Dropbox, you have tutorials. So you have to use the tutorials to make sure you master adding vectors and solving equilibrium. Okay, you cannot rely only on those lectures. It's just because I've been teaching the same stuff for the last 20 years, so it looks easy, but it's not easy, okay? Don't be fooled. You really have to study. Okay, that said, motivational talk. Here, I'm going to take like a tangent, like little tangent, to go over some typical questions. So here about inclined plane. Okay, so first I want you to memorize that each time you have an inclined plane, okay, you have for sure two forces. Maybe it won't be the only ones, okay? Maybe you're gonna have friction, maybe you're gonna pull with a pulley, maybe you're gonna push, whatever, but at least you always have two forces. You have the normal force, which is perpendicular to the surface, and again, you have to imagine any surface is made of those tiny little molecules that you can squish, and they squish back, okay? They push back. So this is called sometimes the support force, but it doesn't have to be perpendicular to the ground. And then you have the weight. The thing that I want you to memorize is always take the x-axis along the plane, along the slope. So if the x-axis is here, then you're going to find the y-axis here. Of course, it's going to be perpendicular. The other thing I want you to do, any problem in physics, those kind of problems when it becomes more complex, always arrange the x-axis such as, or the y-axis such as the acceleration has to be positive. It will make the solving of different equations with different unknown easier. Example, if this is going down slope, then take this to be positive and here to be negative. Let's say it's accelerating, okay? So that way I make sure my acceleration is positive. Other thing to memorize, that angle here will be equals to this angle there. Okay, memorize that configuration. The weight is straight to the center of the earth. So if you have the earth and you have your inclined plane, the weight here is straight here to the center of the earth, okay? Because it's the center of the earth that is generating gravity. So you want to make sure that will be the weight. Is that clear? Now, I want you to memorize that the x component of the weight for an inclined plane, and it will save you a lot of time, equals mg sine the angle of the inclined plane. I want you to memorize that the y component of the weight is always equals to mg cosine. Okay, you memorize it. So for inclined plane, it will make your job easier. And you see that each component has a different job and a different consequence. The x component of the weight, if there is no friction, make it go down slope. The y component of the weight has a different job. It's pushing in the in the snow or in the incline here. So there is a pushback. Now the normal force here will be always your apparent weight. Okay, so it means if you find a way to find your weight here, okay, you see that your apparent weight will be less than your weight. Okay, so that will be the normal force. Typical question, easy. Let's say the mass, let's take an example. Let's say the mass is 50 kilogram. And to simplify, I like to say that G in magnitude is 10, so that will be the acceleration due to gravity. So the weight is 500 Newton. Yes? You agree? So what's the acceleration? So let's say there is no friction. So we're going to apply Newton's second law. And you see, this one is positive, so it's accelerating in this direction. So I take that one to be positive. So you see, it's the down slope here. So I'm going to call that, I don't know, left. Okay, is winning equals mass times acceleration. So what is pulling to the left? The x component. So when you're going to apply Newton's second law, you say the winner minus the loser equals mass times acceleration. And what is winner means the one providing the positive acceleration. So here you don't have loser because there is nothing to counteract because there is no friction. So you're going to say mg sine theta equals ma. So you see that when you have an inclined plane, that component either helps with the motion, or if you are pulling in this direction, it's going to be against you. Okay, you have to work against gravity. So in that case, it's going down slope. So you have this acceleration. So we can say that A equals 10 acceleration to gravity times sine 40, whatever it is. But you see, gravity is diluted. If I make, of course, that angle 90 degrees, okay, of course, the mass now, there is no normal force, n equals 0. Okay, so it will be A equals 10 sine 90. Of course, it's going to be 10, so it's going to be in free fall. Okay, so the amount of dilution depends on the angle. Smaller is the angle, larger is the dilution. Is that clear? So let's take the same example now, but let's say that you have kinetic friction. Let's say that you have kinetic friction. And what's the acceleration now? Can you do that? What did you find for the acceleration here? Not this one. 10 sine 40, how much is that? 6.4? Okay. Is that clear? So now we do the same thing. Okay, draw the situation such as it's still accelerating down, so gravity is helping, but now we have kinetic friction. This one. Now there is kinetic friction. What's going to happen? Okay, are you doing it? Okay, so same idea. You take you memorize this, and then you walk only along the x-axis. Okay, it's still going down. So acceleration is this direction, that's going to be a plus. You still have those two forces, but now I'm going to add another force here. Okay, it's along the surface, so that will be kinetic friction. So friction always opposes the motion. Okay, so it makes it go slower. So this way is positive. Okay, so I'm going to do wind minus loose equals mass times acceleration. So what is making the thing happen? Gravity, but only the x component, so mg sign, and I told you you memorize it, okay? That will be the x component. How much of the weight is along the x, and only this x component makes the motion forward happen. Minus, that's the one that is opposite, okay? And it's friction, and the friction is 121, okay, equals mass is 50 times acceleration, okay? So now you see it's going to depend on the mass. Remember before, without friction we get acceleration is j sine 40 without friction. So everything happens, it's in free fall, because regardless of the mass, any block here will have the same acceleration. So it's a free fall situation, so it's not mass dependent, but acceleration is diluted. Okay? Gravity is diluted. So without friction, it's in free fall. That's how genius was Galileo when he designed those inclined plane, because that was a way to study free fall at a time when there was no electronics. So anyway, so what you get? So mg, that's 321. Is that right? So 321 minus 121 and divide by 50, and you get 4. So you see the acceleration now is less than before. Is that clear? You see how it works, how you apply Newton's second law. And now, okay, so let's take another situation. Okay, another situation. Yeah. mg sine, so this is 50 times. Right? Do you find that? Make sure you are in degrees, not in radians. Okay, everyone is on board? Okay, so you have your inclined plane. First thing, any situation you have, always you draw those two components here. That will be the angle. You memorize it. Now, let's say another situation. Okay, and you apply a force. You need to go to see the physical therapist here. I don't know. So you apply a force here. Force apply, and you still have some friction. You still have friction here, kinetic friction. And now, so this will be positive, okay? I like to take positive wherever it's moving. But now the acceleration is 0. Okay? So that means whatever is pulling to the right had to be balanced to whatever is pulling to the left. And I'm only considering here the x-axis, because along the y-axis it's a different story. Okay, they're already killing each other, nothing is happening. Everything happens along the x-axis here, along the inclined plane. Question? Find what? find the acceleration, and the applied force is, oh, no, the acceleration is 0. So find the applied force, so the acceleration is 0. The kinetic friction is 121 Newton. The mass is still 50 kilogram, and the J is still 10 meter per second per second. Okay, so it's moving in this direction. There is no winner. Okay, so that means everything, right, has to be equals to everything left. So if I call that to the right and this is left. Okay, so you want to make sure they cancel each other. So what is pulling to the right? The force applied, yes? Now, gravity has decided to be against you. Of course, it's going to be, see, he has to tie a rope against his waist because it's hard. And I'm sure you have some kind of workout when you do this. Okay, you go up slope and I don't know, you put a tire and you try to climb. Okay, so what is pulling to the left? You have? Exactly, so mg sine the angle. Okay, so in that case, if you use this way, you just do magnitude. Okay, so what is applied? That's what I'm trying to find. What is the friction is 121 plus this is 500 sine 40. Okay, and what do you get? So 121 plus 50 sine 40. Yeah, 500. So 500 sine 40 plus 121. 442. Okay? Because whatever is to the right, so 442 minus the one that work against you, so you have the friction, and then you have the x component of the weight, and you get 0. Okay, so that means the acceleration is 0, so it means it's moving at constant speed. That will be only true if you overcome static friction first. Is that clear? So you have to understand that finding components is very important because they will tell you how much of the force is along axis, and the x-axis here, the x component does not have the same job as the y component. Is that clear? Yes, are you with me? So it's not hard. Now I forgot to give you. The video I was trying to find. I found it, but I'm losing. Okay. So typical question on the test, for example.
Here I have a circle with the segment of the circle removed, and I'll roll the ball in the circle like so. Now the question is, which can...
So remember, for something to go in a circular track, you need a force to push toward the center, which is a centripetal force, so it has a centripetal acceleration. As long as there is no more force, it will go in a straight line at a constant speed, okay? Like the Wanted movie, does not make sense.
Will the ball hit when it exits the circle? Will it roll around to hit the yellow can? Will it continue in a straight line to hit the white can? Or will it continue in a circular path to hit the green can?
So what do you think? White one?
Right, let's roll the ball to find out what happens. So as you can see, it hit the white can. While the ball was in the circle was keeping the ball in a circular path. Once the ball left the circle, there was nothing to act on the ball to keep it in a circular path, and the ball wanted to continue going in a straight line.
Okay, so that's interesting. Let's see. I had like inclined plane. You see, so you see the weight has two components. That's the one that you want always. You memorize that. Mg sine is along the slope. Mg cosine is perpendicular. So in that case here, the normal force here equals mg cosine. And you have a kinetic friction opposing the motion. So you can find the acceleration, right? So it will be the winner minus the loser equals acceleration over the mass. The net force, if you use your vector skill to find the net force, you see this one kills that one, so they kill each other out. And then you have left here and right. So the net force will be this minus that. So the net force will be somewhere there. The net force is always parallel to the acceleration. Okay? Next. So let's talk about this because it's typical questions to torture students. So I will try to give you some hints, some way methodology. So we talk about that, okay? So the key here, so these problems are called several object system, and so you have one book, a second book, and the secret here, and I put a copyright here, is to have an imaginary bag and to place in that bag whatever system you are looking at. So let's solve something like this here. So it's a typical problem. Sometimes you have variation because they can add some friction. So this one is a simple one. So the way you do it, so they want to find the force that the 2 kilogram apply on the 1 kilogram. So you see, according to Newton third law, sorry, you see, so I'm going to call that object 1, and this is object 2. You know, you have thing 1 and thing 2. So that force here will be F1 on 2, and you also have a force here which is F2 on 1. Is that clear? So the first step, you take your imaginary bag. No, I should use a brown for a bag. A potato bag here. And you're going to place both of them in that bag. Okay, so this is my bag here. Put everything here. So in that case, you don't see what's going on inside because inside they kill each other out. Okay, you only consider the outside force, right? So now your bag, what's the mass of your bag? 3 kilograms. What is the only force acting on it? 6 Newton. Very good. So in that case, apply Newton's second law. Okay, net force is 6. So the net force equals mass times acceleration. We are along the x-axis here, plus, minus. So you do have an acceleration here. So the net force is 6 equals 3 times a. So your acceleration is going to be 2 meters per second per second. Okay? So that will be the first step. And then you take an eraser. I'm going to erase. If I erase everything, that's not good. Okay. It's very satisfying though. It's fun to do that. But okay, let's. Okay, so then you take again your bag. Let's take a bag. And let's just use this one. Okay, so let's put in the bag only the 2 kilogram. So that's your new bag. And then you consider, so remember this one is acting on it and this one is pushing back. So this one is 1 to 2 and this one is F to 1. So now I have a bag. What is inside the bag? 2 kilogram. What is the force acting on it? It's just what is touching the bag? You see, it's 1, 2. So it's being pushed, is being touched by the first block. The 6 Newton is not touching it. You want to use only the outside force, right? Don't worry, because when I say a force like this, it means like that, right? You can put it here. So 1, 1, 2, 2. Is that clear? So now can I solve for F1 and 2? Does it have the same acceleration? Of course it has the same acceleration. Why not? Okay, they move together. So the acceleration is 2 meters per second per second. So I'm considering only that object here, right? So what's going to be the force equals the mass times the acceleration. So the force will be 4. Is that clear? Okay, so the secret is just to have you bring with you some bag, like potato bag. Okay, so let's take this one now. Let's take this one. Okay, I should, my mistake maybe is to put this one. This one is like pushed, it's being pushed back. Okay, you cannot push without being pushed, and you cannot push harder than you are being pushed. Yes or no? Yes or no? Okay, so let's see what's in that bag. So in that bag, what's the mass? 1 kilogram. It's being touched by the applied force, yes? So I should put 6 Newton. But what else is touching it? The 2 kilogram. For every action you have a reaction, right? So what's going to be that force here? 4. Okay? If I push you, you push me, I push you, so it's the same, right? 4. So it's going to be 4 Newton. So it's winning in that direction, so that will be the acceleration. So winner minus loser equals mass times acceleration. Let's see. Winner minus loser equals 1 times 2. Let's check. 6 minus 4 is 2 equals 2. Check. Is that clear? So it's not that easy. And what else? So okay, so you can even make it more complicated. You could do the same thing, but now you can add some friction. So let's say you add some friction here of 1 Newton. So again, the first step is to put everything in a bag. Okay, so that will be my bag now. And I have my bag. So what's the mass of my bag? So 3 kilogram. Which one is winning? The 6. And what is the loser? The 1. You are walking against. Okay, it's walking against you. And that will be acceleration here positive. I want that to be positive. So winner 6 minus loser 1 equals mass times acceleration. Okay, so it's a variation. So same thing, when you're going to consider the different blocks, then each time you will have 1 Newton working against it, but it's the same idea. Okay, you still have that force here applied to this block, and a force here applied to that block, action, reaction, you push me, I push you. I cannot push you more than you are pushing me. That's the idea. Okay, so that's how it works. So interesting video here. Very, very interesting.
Here I have a magnet, and if I place it on this base,
Okay, are you with me? So he has a magnet, and he has a scale.
and read the scale, it reads 56 grams. Now this base allows the magnet to float a few centimeters above it. When I place the magnet on the scale so it will float, what will the scale read? Will it read 0 grams, 56 grams, or negative 56 grams?
So it means he's gonna place, because it's magnetic, so it's gonna float above the scale. Do you think it's gonna read the same thing? Yeah.
So I place the magnet on the base, and the scale reads 56 grams.
Isn't that cool?
Now the scale doesn't read 0, it reads 56 grams because of Newton's third law. The base is pushing up on the magnet to keep it floating, but in the same time, the magnet is pushing back down on the base with the same amount of force.
So to understand that, it's the same idea, okay? So it means you have your scale, and okay, let's say it's magnetic, so that's part of the scale here. And now you have your magnet. So it's a magnet here, so it has a north here and the south. So it's gonna be repelled. Okay, it's being repelled. So if it's repelling, it means there is a force here, which is a magnetic force. And here you have the weight. Do you agree with that? I'm just looking at my magnet, so that's going to be my bag here. I have my bag here. I'm looking at my magnet. It's in equilibrium. So because it's equilibrium, what can I do? They equal to each other. Acceleration is 0. So the magnetic force equals the weight of the magnet. Yes? But now I put my scale in a bag. So what is Newton telling us? If the scale push the magnet up, repel the magnet, so the magnet is going to push the scale down. Excellent. Right? And you still have the normal force here, so of course it's going to be in equilibrium. Okay, so you're going to push down the scale with that magnetic force. Isn't that interesting? You should do an experiment like that. I don't think it's too hard to design, but it illustrates Newton's third law. You cannot push without being pushed, and it illustrates the several components. So let's consider something like this first, and always think loser and winner. So of course the mass here is larger, so it's going to accelerate. This one is going to accelerate which way? Down, okay? So here I'm going to take my acceleration A for this one, okay? I'm only working on that one, and that's going to be plus because I want my acceleration to be positive. This one is going to accelerate up. So it's going to be the same acceleration, but now the acceleration is up, but the same magnitude. I'm going to take plus up. Now I'm going to consider only this one, only that M. So I take that M here in my bag, and it's accelerating down. So is there a winner or is it in equilibrium? There is a winner. Which one is driving the mass down and providing with the acceleration? What is pulling down? The weight, right? The earth grabs it and pull it down. So you're gonna have the weight. But can I say that it's in free fall? No, what is working against it? The tension. Okay, there is a tension here. So if I do the tension, should I do it exactly like the weight, smaller or larger? Because which one is winning? Down is winning, right? The winner is always the largest. So the tension will be up, but smaller. Okay? It makes sense? Because the acceleration is down. So you're going to have mg. Okay, so if I only consider this one, okay, it's going to be mg minus t equals m times the acceleration for this one. I want always the acceleration to be down. Is that clear? Let's consider this one. It's going up, right? Do you all agree with that? So if it's going up, which one is the winner? Up or down? Up is the winner, right? So M, so what is winning? Which force is winning? The tension is winning. So you have the tension, and actually I should do it on scale because it's going to be the same tension that before. Okay, the same tension. Because remember when you have a pulley and it's no friction here, and you have a rope here, it has no mass, let's say, the tension is transmitted. So it's going to be the same tension. So how do I do the small weight? Smaller than t, larger than t, or the same? Smaller, very good. Okay, and I want to make sure that my acceleration is the same, but positive is up. So I can say winner minus loser equals ma. You see? So I have another equation where I say t minus mg equals ma. Okay? Is that clear? So you see here, it's very simple because then you can say, look what's going to happen. Add those two equations together. You have a minus t and a t, so it goes. It's going to be mg minus small mg equals exactly. Do you all agree? That's easy, okay? Is that clear? Right? So you see that the acceleration will be m minus small m g over m plus m in that case. Okay, that's one way to solve. But my point is always look at the winner, the loser, make the winner in the same direction as the acceleration. Okay? And I had like an example, but you're fine, right? Don't need some example here. Now, a different way to do it, and I will show you a different way. But is that clear for now? Are we good? Okay. Don't space out.
Question.
Yes.
Still kind of confused on the steps you did with blocks.
Which one?
How you went from the whole bag to the larger and then to this.
Yeah? For this one?
The second step.
No, the first step, if you need to, you find the acceleration. First step, you find the acceleration because the acceleration is the same for everything. So in that case, you put the two back together. So that's going to be 3 kilograms, and the only force acting on it is 6 Newton. So from there, you find the acceleration. So the acceleration is 2 meters per second per second. And then you take this one. So if you take that 2 kilogram here, the only force acting on it, it's whatever is touching it, right? So that will be that force here of block 1 on block 2, but it has the same acceleration. So the winner is 1, 2 equals the mass, which is 2 times 2, which is 4 Newton. Okay, now if you take this one in your bag, so that will be 1 kilogram. What is touching it? 6 Newton is touching it. This force is touching it because you cannot touch without being touched, and you cannot be touched more than you are touching. And so in that case, those forces are equal, so it's going to be 4. So you have winner 6 minus 4 equals 1 times acceleration, and you also find the acceleration to be 2.
Second step, because they're not separated from each other, it's basically in equilibrium. So it would be 4 newtons in one direction and 4 in the other.
So if it's here, but so if you take the whole bag, yes, 4 Newton to the right, 4 Newton to the left are killing each other. So it really depends what is the system that you are considering. So if the force is something that you learn in chemistry, you know, in chemistry, you take to derive the perfect gas law. You see, you take a gas, and all those gas molecules, they interact with each other, right? It's very complex, but because of Newton's third law, if you consider the gas here like a system, a closed system, whatever is happening between them, it's not your business. All the forces will kill each other out because of Newton's third law. Right? Okay. Let's take another typical question. And you have 2 ways to do it. Like you had 2 ways to do it before, but I didn't build on that. What I would like you to do here is, you see, you have no friction. Okay, let's say you have no friction. So now you have a pulley. So if there is no pull, if there is no, let's say this is 10 kilogram and this is 50 kilogram. If there is no friction, it will still move. Don't think because this one is 50 kilogram, it's not going to move. It's going to move. The only thing that prevents you from moving is when you have static friction. As long as you have no friction, it's going to move. It's going to move slowly, but it will move. So it's like when I show you this one, it's a great simulation. Here, if I take no friction, okay, so that's easy, okay. I take now if I take something very heavy, and it's gonna harder. Maybe it's not a good idea here. So if I take this and on top of that, and I have no friction, it's still going to move. It's gonna be tiny, but it's still moving. Okay, it's still moving. So in that case, if there is no friction, even though that mass is smaller, it's still moving. Is that clear? So you have different ways to do it. I will show you a secret way. So first of all, consider this one. So acceleration here is positive. Do we have a winner? What is the winner? The weight down, 100 Newton. Do we have a loser? The tension. Is the tension smaller or equal to if you do have an acceleration? It's going to be smaller, T. Do you agree? And then I'm going to look at this one. What's going to be that force here? Tension. Do you agree that's going to be the same? Tension is always transmitted. Yes? And so it's going to be T here. Okay, so you have 2 ways to do it. The long way, you're going to put this one in a bag. Okay, so I have my 10 kilogram in a bag. And this one is pulling in this direction, T. And this one that's 10 kilogram is 100 Newton. Okay, so we can say that 100, the winner, minus what is the loser? Tension, equals, what's the mass? 10 times acceleration. And then I have a second equation for this one. What is the winner? T. Do I have a loser? No, no loser because there is no friction. Equals mass. What's the mass? 50 times acceleration. So you see it's easy. That's one way to do it. You add equation 1, equation 2. So you're going to have 100 equals 50 banana plus 10 banana is 60 banana. And that's going to be 100 divided by 60, which is about 1.7 meter per second. Is that clear? But let's do it a different way that will go even quicker. Let's take a bag. So I take a bag, okay, my potato bag, copyrighted, and I'm going to take the whole thing in a bag. Okay, it doesn't know what's going on. It doesn't know about the pulley. I put everything in a bag, okay, a big bag here. So now, do we worry about the T? No, they kill each other out. So what's the winner in that case? Pulling the bag. Gravity, the weight, which is 100, yes? Equals, what's the total inertia? How heavy is your bag? 60 times acceleration. And you find the same thing, except it's the way to go faster. You see? Instead of having two equations with two unknown, boom, solved, check. Okay? So everything depends what you're gonna put in your bag. So with pulley, it's gonna work, except in some case when you have something attached to a wall, for example, it won't work. But otherwise, that works great. Okay, so can you now do the same problem, but now you have a friction. Let's introduce friction. So when there is friction, it could be more tricky because sometimes it's not going to move, right? If you have less mass here, more mass here, plus friction, sometimes it doesn't move. So let's put a friction force here of 40 Newton. Let's say it's kinetic friction. So solve the problem. Can you do it? So you could do it in two equations with two unknown, but let's take a shortcut and put both mass in a bag. And the bag is accelerating down. You can do that. You can have an imaginary bag. That's no problem. No one tells you not to do that. So don't stare. Are you doing it? Okay, so now we have friction. So it's an external force, external to the bag. It's not inside the bag. The earth, Mother Nature here, grab the bag and pull it down. Of course, this one also have a normal force here. And this one also have a weight here, so that would be 500 Newton, but we don't care because we are just looking at the direction where you have an acceleration. Along the y-axis here, you have n equals 500. I'm going to call that n sub 1, but we don't care here. We are just interested by this motion. Is that clear? Okay, so what is the winner? Okay, so the winner, the driving force. Gravity, right? gravity is the winner, minus what is opposing that motion? Friction. What is the mass of the bag? 60 times A. So winner minus loser is 60 equals 60A. So A equals 1 meter per second. Now you could have done it a different way. If you like to make your life harder, it's your choice. You can do that. So in that case, you take each one you take it separately, okay? So you take this one, 10 kilogram. The winner is 100. The loser is still T. So you have 100 minus T equals 10 times acceleration. Okay, so that's one equation. And then you have this one in a bag. So this one you have, that's 50 kilograms. So you have T winning. And you have a 40 Newton here. Okay, you also have down and up, but we don't care because we want to look at this direction. And here we look at this direction. So you're going to have T minus 40 equals 50 times acceleration. So you have two equations with two unknowns. That you can do as well. But this way, go faster. Is that clear? You will get the same thing. You add them up, the T will disappear, and you solve for A. Are you with me? We are getting more serious now, right? So let's try a more complicated one. Now let's try an easy one. Okay, talk to each other, help each other. So hopefully you start to understand that everything depends on your system. What about here? The question is, I don't know if you can see here, it's in gray. So here you have tension. And the question is, find the relationship between P and T. So P here is the applied force, okay? This is someone here pulling. And there is no acceleration, okay? It's in equilibrium. Equilibrium means acceleration equals 0, so that means up equals down. Okay, so you can, for example, you can take this in a bag, the whole thing. And of course you have a tension here and a tension there. But it doesn't matter, it's inside your bag, right? So what is pulling up that bag? Up, it's the P, right? We don't know. Yes, you're right, it's going to be 125. And down, it's going to be 125. Do you all agree with that? So this is an outside force because the earth grab and the earth is outside. And I am outside, so this is me here. I am outside, so up equals down, so you're going to have P equals 125 Newton. Yes? Is that clear? Now let's consider only this one. And it's in equilibrium as well, so I didn't draw it well. This should be the same as this one. So let's take only this one. So what is pulling down? The weight. So what's the weight of 100? It's going to be 100, right? What is pulling up? Tension. So if it's in equilibrium, the tension equals 100. So what's the relationship between T and P? P equals T plus 25, right? You see? So the idea is always have something in a bag. You can think of bag. So here it's not great because that force here should be, this should be equals to that, and this should be equals to that because it's in equilibrium. So that's how it works. Okay, so let's make it, let's keep going. Let's try to do this one. So this one, I don't know what the question is. This one is 10 kilogram, and this one is 60 kilogram. No, 6 kilogram, 6 kilogram. Oh, 6 kilogram. And you want to find the acceleration. Okay, first thing, you see you have an inclined plane. You don't stare. You draw the normal force and the x component of the weight and the y component of the weight. First thing, as soon as you see an inclined plane. Then you say, okay, it's going down. Okay, it's accelerating down. So you can place everything in a bag. See what you're going to get. Okay, so you're doing it. So first thing, come first, don't stare. It's an inclined plane. So you want to draw the y component of the weight and the x component of the weight always, and you memorize that the x component of the weight is mg sine and the y component of the weight is mg cosine. So you don't have to pull hairs each time. So you can help each other, talk to each other, blah blah blah. Help each other, okay? So first thing, when you have such problem, always have the x-axis here along the plane. So of course, that's going to be your y-axis. So this one is going to go down. It has an acceleration. This one is going to move up. It has an acceleration. Of course, it's going to be the same acceleration. And I want the acceleration to be positive. Okay, so this way it's going to be positive. Down is going to be positive. So let's first draw the force, and this is 6 kilograms. This is 6 here. So which one is winning? The down or the up? Down. Okay, so we make it bigger. And how much is down? 6 times 10 is about 60. Do you all agree with this? Okay. And what is that? Less than 60, you're right. So that will be the tension. The tension transmits itself, boom, 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 here. Okay. And because it's an inclined plane, you're going to have the x component of the weight always down slope. You have to memorize that, always down slope. The weight is straight in this direction, but it's easy to draw. And what's the x component of the weight? Is mg sine. Okay, you memorize it. And of course you have the y component mg cosine, and here you have the normal force here. So along the vertical, for this mass here, the normal force, is fighting with the mg cosine and they are killing each other. Obviously, you don't see the block going into space. It's in equilibrium. If it was not equilibrium, it will break the slope, right? It might happen if it's like an elephant that you put on a slope, you might break it. But if it doesn't break, then it's in equilibrium. Is that clear? Okay, so do it, don't stare. So I'm considering this motion here, and one way to do it, I'm going to take a bag. Okay, my bag here, it's going to be this. That's my bag. And the bag doesn't know about the pulley of anything. The bag only knows that it's accelerating with acceleration A. And the bag knows about the driving force and the opposing force. It doesn't know what's going on inside. Is that clear? Okay, so do it. The winner, as long as this bag is concerned here, okay, along here, see it's being accelerating. Okay, if you don't like this way, you can decompose in two parts. Okay, so do it. Don't stare. I see people staring. More you stare, more work you have at home. Don't stare. Do it. Not yet. The only one that is fighting you is the mg sign. So we always suppose acceleration is positive, and if we get a negative number, it means it's moving in the opposite direction. Okay, so the bag, as long as the bag is concerned, the bag here, as long as the bag is concerned, you're gonna have inside the bag what is 16 kilogram. As long as the bag is concerned, it's going accelerating in this direction. As far as it is concerned, there is a winning force here, and there is an annoying force here, mg sign. That's from the point of view of that bag. It doesn't know, it doesn't have eyes, it doesn't know it's placed on the inclined plane. All it knows it's moving forward, it's spinning up, so all it knows it must have a winning force and a losing force. That's all it need to know. Yeah.
If it's a bag, wouldn't the entire, like, how can you have mg sine theta if there's no friction? It would just be the difference of the two weights.
No. You always have mg sign. Each time there is a mass, here you always have mg sign. But it's an imaginary bag. It's not a real bag. Okay? And the only force acting is mg sign because of that one here. Okay, that will be the force. Now, if I will show you the different way to do it. So first you do that. So do you agree that you have mg? Mg will be 10 times g sine 30. If what? So what's the winning? So 60 minus, but here, be careful, it's mg. This is the one placed on the inclined plane. So it's going to be 10 times 10 sine 30 equals, what's the total mass? 16 times acceleration, right? Do you agree? I would do it a different way, but this is 10 here. So what you get?
0.5.
0.5 only?
It's 10 times 10, which is 100, times sine of 30.
Which is 0.5.
Oh, 50.
Yeah, your mg sine is 10.
So you'd be 50.
So 0.625. Right? No, the mg sign, it depends on the 10. This is 10 kilogram and this is 6 kilogram. Right? Okay? If you don't like this way, if it's confusing, okay, let's decompose. Let's decompose. If this is confusing, what is the driving force? 60 minus what is the losing force? Tension equals, what's the mass? 6 times acceleration. Second equation, just for this one, what is the winning force? T minus, what's the losing force? So 100 sine 30 equals, what's the mass? 10 times acceleration. So if you combine them together, if you do 1 plus 2, you're going to have 60 minus 100 sine 30 equals 16a. And you get the same thing. Just a trick to go faster. But you don't have to use the trick if you think it's too hard. Okay? So you have two ways to do it. You just have to do, if you put the bag here, you just think, what is the winner? What is the loser? The loser is because of this one. Once you have shown, you have to show all the forces first. Is that clear? Now, if I have friction of 5 Newton, okay, modify. If you don't like my bag, it's fine. You do it the long way. So if we do it the long way, add some friction. Add a friction of 5 to see what we get. With the friction of 5. And let's see what we get, okay? So let's do all the force. I told you, you memorize that force here is the weight along the plane, so mg is 30 degrees. You always have a normal force here. The normal force is always balanced by the mg cosine. And now you have some friction. Let's add some friction, opposite to the left. That's going to be friction here. You still have your tension here. You have your tension there. And you have your weight here, which is 60 Newton. And it's accelerating, so you have acceleration here, acceleration there. So can you write the two equations if you don't like my bag? So this one is what? Which one is winning? 60 minus, which one is losing? T equals, what's the mass? 6 times acceleration, yes? 2. What is the winner? T minus, what is the one that are against the winner? You have friction, yes? So it's going to be friction is 10 minus mg, it's 100 sine 30 equals the mass times acceleration. Okay? And if you do 1 plus 2, you're going to get 60 minus 5 minus sine 30 equals 16a. And you can find a. So that should be easy. Yes? If you put everything in a bag, it's going to be easier. But I don't know if you like it. Is that clear? I'm losing everyone. Everyone is leaving. So I don't know if it's too hard or it's too easy.
Last question. You got 60 minus 5.
Yeah.
What happens to the 100 sine 30?
It should be there.
It's supposed to be 60 minus 5 minus 100.
Minus, so it should be 60 minus 5 minus 100 sine 30 equals 16a. Okay? And what's going to be the acceleration in that case? Thank you. 0.312 meter per second. Okay? So if you don't want to put everything in a bag, you can do it this way. It will give you the same thing. Is that clear? Am I losing everyone? I see people leaving, so I start to worry. Okay, let's do another one. I got you, baby. Do 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 do.
Yeah, no, I think it's right.
Let's say you have a 5 kilogram, and here we have a 10 kilogram. Okay, and here I'm pulling here. So this is the 30 degrees, and someone is pulling. So I don't know what's the question. Oh, the acceleration. The acceleration is the acceleration is 0.5. Oh my God! Oh, that's nothing. Oh my God! You think it's something? Wait. So applied. I have to make it a little bit hard. No, it's a calculus class. Not my fault. No. Okay, so x-axis here, y-axis there, and you have a pulling force here applied, and you have the acceleration. Okay, your turn. Find the applied force. And remember, a force comes into two components, right? It has a x component and it has a y component. And of course, you have the weight here, we don't care. And you have a normal force here. For now, we are not interested. And here you have a 50 Newton force. And it's going in this direction. Okay, so you have a tension here. Oh, by the way, the tension has to be larger or smaller than the 50? Wait, it's going this way. It should be larger, right? If you do it right. So you have a tension here. That's going to be smaller. Are you doing it? 50 Newton. So 50 Newton is moving up, and this one is moving along the x-axis. So you don't like my bag, so I'm gonna do in 2 steps. So this one, just consider this one. What is the winner? What is the force that make it go forward? Very good, the x component. Very good, excellent. Only the x component, right? So F sub x. What is working against it? Minus the tension equals, what is the mass? 10, very good. Do we have the acceleration? Very good. Number 2, which one Which one is the winner? This one. Tension, very good. Minus, what is the loser? Very good. What is the mass? Very good.
So
What is the...
0.5.
Very good. Excellent.
And then you do the line meter.
Exactly. That's Daniel, right? You see, it's not that hard. So you do the x component, minus 50 equals 10 banana plus 5 banana is 15 banana. 15 the banana divided by 2 is 7.5.
Why did you divide it by 2 bananas?
I know, because I make things complicated. You just do 5 plus 2.5 is 7.5. Right? So the x component equals 50 plus 7.5, which is?
7.5.
Yes. So can you find the force F? So the total force equals, so the x component is the force applied times...
Is it f of x times f of x?
No, it's a multiplication.
Oh, okay.
So x component equals the magnitude times x component. If you use the polar graph and you go counterclockwise.
The mg sine 30.
No. Look, it's a vector. We're talking about a vector. You have a vector here, and this is the x component, this is the y component, and this is 30 degrees, right?
So
the magnitude.
the magnitude, you just do the square root.
The square root? No, because I could. Okay, that's one way, but it's more complicated because you have the normal force here. So you have a right angle triangle, cosine, right? You remember cosine is always the x component, right? So it's going to be f cosine 30. So f equals...
Yeah, I was not there.
Keep going. So 57.
36.30.
What?
66.4.
66.4 Newton. You see how it works? Right? Are you with me, guys? So that's why you have to master trick, okay? So it's the story is winner minus loser equals mass times acceleration. Always take the acceleration in the positive direction. And I think my bag didn't have success, so but it worked. Okay, you can take a bag here, it will work too. But maybe it's too complicated.
Can you do it?
Yes. So if I take the bag, so I have a bag, but then I have to use those forces that I see here. So if I do the bag, I say, what's the mass of my bag? It's gonna be 15 kilograms. And what is my bag is feeling a force this way, which is the x component. And what is pulling this way is the 50 Newton, and it's accelerating in this direction. Okay? From the point of view of this bag, doesn't know the architecture, it doesn't know what it looks like. My bag, so you can put a bag here, all it knows, there is a pulling force, there is a winner, and there is a loser. That's all my bag knows, right? So you say winner minus loser equals the 15 times acceleration, and you take a shortcut. It's a shortcut. Okay? You get the same thing. But if you do it this way, remember what's the winner, what's the loser, and that you have a bag. Because why is that? Because the teeth here are inside the bag, so they are killing each other. So f of x is still, once you find f of x, it's still gonna be f cosine 30. So you will get the same thing. So you take that triangle here. This is the x component doing the work. I mean, that x component is the driving force. This component here, the y component, is lifting. Its job to lift and to decrease friction, if any. So along the y, you see that 100 down equals the normal force and F sub y. Along the y, you are pulling up. So along the y, you have F sub y plus normal force equals 100. That will be a third equation. Up equals down. Okay? And winner minus loser equals mass times acceleration. Is that clear? Take too much time. Are you with me? Okay, let me ask you something tricky. Let's say I have two box crate. You know the crate, 50 kilogram and 50 kilogram here. Time goes too slow and no, too fast. Yeah, this guy is applying the force where? To the bottom? Bottom, very good. Very good. Okay? So the guy, I don't know if it's a guy, by the way, but he's pushing. The applied force is here. Do you agree? Okay. So if the applied force, I don't know, is 100 Newton, okay? So I take everything in a bag. First of all, what is my system? It's going to be those two here, yes? Okay. So it's going to be what? The acceleration will be, so we know there is no loser, mass. So the acceleration will be, very good. Now I'm confused. I'm confused because look, what if I put this one in a bag?
There is no force.
Is there no force? Because if there is no force, it will fall. It doesn't fall. There is friction between what and what?
Thing and the
Exactly. Imagine this is icy. If you push the bottom, this one is going to be left behind. If it's moving, it means there is friction between both of them, right? So it means you're going to have friction between those two boxes. Okay, so that's box number one. That's box number two. The friction takes with it this box here. So 1 to 2. Now, if there is friction, if this one is pulling this box, what's the reaction? You're gonna have another force here. Okay? You cannot push without being pushed. You should do that at home. You take two boxes, like a shoe boxes, and you pull them. If you go slowly, the top box is going with the first box, right? Because of friction. If you push very hard, it's gonna fall behind. Is that clear? Now, if I put this one in the bag, what's gonna be my equation? What is the winning force? Only this one in the bag. It's gonna be, is it the applied force? Is it the 100? No. It's the static force, right? So it's going to be F12 equals, what is in my bag? 50. What is the acceleration? 1. So that force here will be 50 Newton. And that force here will be 50 Newton. You see how it works? For every action, you have a reaction, and it all depends on your bag. So it's a small step for us and giant step for humanity. I don't know. It's a big step that we did today, right? It's not easy. We will do on Thursday. We'll do equilibrium. If you have any question, let me